Okay, so as I said, we're talking about things that appreciate in value. So not just an increase over kind of once, increase several times, year after year or time after time. Okay, so we're going to do some examples based on that. Okay, and the first one you should now see is a teacher's starting salary is for £21,500 and it increases by 2% each year. What will the teacher's wage be after 3 years? Now, I'm going to write down what not to do because this is what a lot of people think you do here, and I'll show you why it doesn't make sense. Okay, what people think you do is you find, so this is, you don't have to write this down, you can just watch me do it. So this is what not to do. So you find 2% of £21,500. Okay, so 2 divided by 100, so 0.02 times 21,500. That's going to equal 0.02 times 21,500. So that's going to equal £430. So it's gone up by £430. So then it's for 3 years. So I just do 430 times 3. And then I add that on. So 430 times 3 is 1,290. So then the kind of final value is the new value, I'll say, is 21,500 plus 1,290. And that gives me a final value of 22,790. Okay, so that's what most people at first think you do. You find 2%, and because it's increasing by 3 years, you just times that increase by 3, and then you add it on. Okay, that would be using simple kind of interest, if you like, simple increase, but that's not how it works actually when you increase something by percentage year after year. Okay, what you have to do is you find 2% of 21,500 and add it on after the first year. Okay, so I'll show you what I mean. So after first year, again, just watch me do this. After first year, the value is 21,500 plus that 2% that I found, which was 430. Okay, that is the case. So you add that on and it's now 21,930. Now here's the trick, and here's how this percentage appreciation works year after year. I'm not then finding 2% of my original value to work out my salary after the next year. I'm now working out 2% of this new value, 21,930. It's a higher number than what I started with. So because I'm taking the same percentage of a higher number, the amount that it's going to go up by is actually more than 430. So I'll show you. So after the second year, we now do 21,930 times 0.02. And we'll get an answer slightly higher than 430 this time. So you can do it with me in the calculator, please, if you've got one, just to check. So it's £438.60. So now I just then need to add that on to this salary. And I get my value after 2 years to be 21,930 plus £438.60. So that's going to be £22,368.60. And then one more year, what I would do is then find 2% of this new salary after 2 years, so 2% of 22,368, and then add it on. And you'll see that the final value is not going to be the same as what we've got down here. So I'll just keep watching me do it. So after the third year, it is £22,368.60 again, times by 0.02. The percentage is staying the same, so it's just always times by 0.02. So the increase this time, as you'll see, is even higher because I'm taking the same percentage of a higher number. So that amount that it's gone up by is even higher. So it's £447.37. So then I add that on to my salary, and that is my new final value. So £447.37. So carefully add these numbers together. So £22,368.60 plus £447.30.37, and it is £22,815.97. So you can see, if you look at this value here and the value we obtained from just simply just finding the 2% then timing it by 3, they're not the same. Okay, and that's because when you do a repeated percentage change, you're finding the percentage of the first value after the first year, which is higher than what you started with, so the amount that it goes up by increases each time. And that's how interest works. So how interest works on savings and interest works on money that you borrow from the bank. I mean, this is typically why, this is when you're working with interest, savings, money, it's all to do with percentages. Okay, so if you have you put £100 into a savings account and the savings rate is 2%, you'll get £2 at the end of that year. So then if you get 2% the next year, it's not 2% of 100, it's 2% of 102 that you would get. So it just slightly increases each time, and the same kind of works with money that you borrow. You get charged interest. And that keeps going up and up and up depending on how much you borrow. Okay, but in terms of this calculation, basically what we have to do each time is you start with the value, you times it by the increase, and then you add it on. Now, what you will be pleased to know is that there's actually a massively simpler way to do what we've just done on the right hand side, and it's using one formula that, if we can learn it and we can find the process to do it, it is a massively useful formula, and it's going to really help us. This is pushing on to Nat 5 level work now. Okay, there's a much simpler way to do this. What we actually did there, if I scroll down a wee bit, and I want you to check this for me in your calculators, all we actually did there is we started with our starting salary, which was 21,500. And we increased it by 2%. So we multiplied it by 1.02. Remember when we did that with a percentage increase decrease last week, 100% add 2% is 102%, divided by 100 is 1.02. So you're just using our multiplier method. So actually, to find it after 1 year, we just times it by 1.02. Then all we did to get the answer after the second year is we can just times it by 1.02 again. Then after the third year, we just times that answer by 1.02. So can you see that we're just doing the same thing every time? We're just multiplying the starting value by the same thing, how many times, which we're asked for in terms of how many years. So this, what I've underlined, that can be simplified massively using powers. So we can actually simplify that even further to say 21,500 multiplied by 1.02. Now I'm just timesing it by itself. How many times? 1, 2, 3 times. So that is the same as times 1.02 to the power of 3. So see what I'm putting in a cloud right now? That is one simple line of working that you can input into your calculator, and it'll take you straight to the final answer. Let's just check it. Okay, so that is 21,500 multiplied by the multiplier as the percentage increase as a decimal multiplier, so increase by 2%, so 1.02, and we've done it 3 times, so it's just to the power of 3. So not times by 3, it's to the power of 3. And if you put that into a calculator, you see you get the exact answer at the end, 22,815.97. Okay, so that is what we're going to do today, is we're going to use this simple formula to calculate some of these repeated percentage changes. Right, and what I need you to do now is copy down this formula. Okay, so This is really, really important, okay? If you're for pushing on further in maths, you know, doesn't matter if you're going on to National 5 Numeracy or if you're going on to National 5 Maths, you're going to be using this in both courses. So very, very important kind of skill to learn. So to calculate a repeated percentage change in appreciation, so that's things that go up, depreciation, things that go down, problems, use the formula. So is the initial value, the initial quantity, so that was the starting salary of the teacher in this case, times by the multiplier, so what was the percentage increase, decrease as a decimal, and then to the power of how many times am I repeating it. Is it over 3 years? It'd be to the power 3. Is it over 5 years? It'd be to the power 5. You know, so copy that down just now, please. It's really, really important. And we'll do a little example underneath. So example which I want you to copy down is just simply increase 5,000 by 8% per year for 5 years. Okay, now if we're doing it the long way, this would take us ages. We'd have to find 8% of 5,000, add it on. That'd be at the end of year 1, then 8% of the new value, then add it on, then 8% of the new value. So that would just take all day. So we're going to use this formula and it's going to take us much, much shorter time. Now the bit of work in these questions is actually getting this multiplier first of all. So that's what we have to do here, and it's the same as we did last week. So it's finding the multiplier for, in this case, it's an increase by 8%. So if you remember, we said we start with 100%, we add on 8%, and that gives me 108%. Now what is that as a decimal? I then just divide that by 100. That gets me to my multiplier, which I just like to put it in a box to make it clear that's what I'm going to use. So 108 divided by 100 is just 1.08. So we know that from last week, hopefully, that if we want to increase something once, we just multiply it by 1.08. So if we want to increase something 5 times, we just multiply it by 1.08 5 times, or to the power of 5. But actually, all we need to do now, once we've got our multiplier, is we've got one line of work in, one thing to put in the calculator, and then we're actually done. So the new value is going to be the initial quantity, 5,000, times by the multiplier, 1.08, to the power of how many times. So it's 8% per year for 5 years. So this is to the power of 5. So it's the multiplier to the power of 5, not the starting value. So if you can just put that into your calculator, making sure you use a power for the 5, you're there. That's it. In the comments, please, can you let me know your answer before I tell you? Just want to check if you can get it yourselves. Don't worry about rounding. Got an answer? Right, so you put that in your calculator, 5,000 times 1.08 to the power of 5, and the number you get at the end for your final value after that increase of 8% over 5 years is £7,345 and 0.6403 ... We're not really asked to round to anything, so just leave it as that. Okay, so we found the multiplier the percentage increase as a decimal, 1.08. We times it by the starting value, and we did that to the power of 5. I've got one more I want to show you. Two more I want to show you, sorry. So just copy down these with me just now. So John puts 3,000 into a savings account offering 2% interest per year. How much will his savings be worth if he leaves the money in the account for 3 years? Okay, so quite a typical situation. You've got some money, you want to put it into a savings account. The bank will offer you interest. That means they will give you a percentage of your money for the purpose of you giving them your money so they can loan it out to people. That's how banks work. So they're offering you 2% interest. So that means whatever your value is at the end of the year, they will pay you 2% of that as and you just get that money basically and add it onto your total. Okay, so what would it be worth after 3 years? So we've got our multiplier for an increase. So that's what an interest is. It's our money on savings. It is our money going up. On borrowing, it would be our money going down. Multiplier for a 2% increase, so that's going to be 100% plus 2% is 102%. Change it to a decimal, 1.02. Okay, so just copy this all with me. So then the final kind of value of savings, just the final value is fine, starts with 3,000. We then multiply it by 1.02, and then we're not just doing that over 1 year, that would just increase it over 1 year. I want to know after 3 years, so it's just to the power of 3. So pop that in your calculator, 3,000 times 1.02 to the power of 3, and it is 3183.624. Now this is money, so therefore I need to round to the second decimal place, the nearest penny. So 3183.62. So if you put that amount of money in after at that interest and leave it for 3 years, basically the interest you will have earned is £183.62. Okay, one more example to show you, which is when we have a kind of decimal percentage. So we've got a classic car. So kind of rare, anything rare basically usually goes up in value. So you will have heard stories of the Aston Martin from one of the first Bond films has sold at auction for £5 million or something, right? That's not at the price of it when it was made, but because of the situation of that car, it's been used in a movie and it's a rare vintage, one of a kind. It means it appreciates in value year after year. It becomes more sought after, and that's the case with a lot of vintage cars. It's the case with a lot of rare items like rare jewelry, rare paintings, rare antiques, that sort of thing. So this particular classic car is forecast to appreciate in value by 5.5% every year. If the car is worth £50,000 presently, what will the value be in 10 years' time? So, multiplier this time is for an increase of 5.5%. So, go through the same process, please. It's 100% plus 5.5%. So, that is 105.5%. Changing that to a decimal number, you just divide it by 100. That decimal point is just going to move back 2 places, and it's going to be 1.055. So then the final value is quite simply just the original initial quantity, the initial value, £50,000, times by the decimal multiplier. How many years am I doing it over? I'm doing it over 10 years, so it's to the power of 10. Again, same as before, just pop that in your calculator and then you should get a final value of 85,000. So it's 85407. I'll just write it out in full and then round it. So 85407.22292. And again, because we're talking about money, which often we will be in these questions, we need to round to the second decimal place, the nearest penny. So £85,407.22. Okay, you're now ready to practice some percentage appreciation problems for yourself.